Hi, Assalamualaikum. So we are from Group 3, which is Al Jazari. So we're going to present about our software, which is named as Ambulan Ku. So how normal emergency call works. The patient need to make a call to MERS 99 and MERS 99 will pass it to the KKM. KKM will find the nearest hospital available based on the location given by the patient, and then it will pass to the hospital. But the problem occurs here when the hospital doesn't have an available ambulance and they need to pass it to the next providers, which is from private sectors such as PBSM, St. John, and etc. So this scenario will cost a lot of time for each cases. So let's see how Ambulance Coup works. So Ambulance Coup works by getting the location from the patient through GPS, and it will automatically choose the nearest ambulance available. So it will list down all the ambulance that are available, whether it is from public hospital, from PBSM, or from private providers. So this thing will fix our previous problem that occurs on the normal emergency call. So ambulance queue will solve and will reduce time that we need to settle down for each emergency cases. Thank you. Let's move to the next presenter.
Okay, next for the problem identification, our main problem is inefficient service of publicly and privately owned ambulance. There are four root causes. Number one, management's failure to activate the response team at nearby hospitals resulted in delays and the failure to achieve KPIs. Number two, the system that now used is not linked with the private ambulance company. Number three, inaccurate location of the incidents reported by the patient. And the last one, borderline problem as the government hospital use zoning method. So our target user is caregivers or those who requires ambulance services. Okay, so for benchmarking, we use Dota2U and MERS 999 applications for our benchmark. As we can see here, our application Ambulanku meets all the user needs requirement. So next, I will pass to the next presenter.
So let's now move on to the design specification. So we have two different user needs. The first one with the precise user location detection with the design attributes of the user location tracking. We have a design characteristic for using global positioning system or GPS that has been installed in our devices with an engineered target of system accurately track user location by sending the longitude and the latitude position to the provider. Next is the ambulance sorting. We sort the available ambulances based on the closest distance. The design characteristic, which is the list of options for the nearest private ambulances, with an engineer target of user can make a choice between private and government ambulance. So now let's go into the design ideas by we are providing a video for these design ideas.
Hi. Welcome to our app named Ambulan Ku. Let's see how it works. First, enter the registered username and password. Then, three buttons will be available to choose, which are Emergency, Other Services, and Profile. Let's dig into the Profile button. So, on the left side is user's profile and the right side is the ambulance's driver profile. Next, we move to Other Services section. The app will offer follow-up outpatient and exchange hospital services for the user. Next, let's see our main function, which is under Emergency button. Patient will be briefed about each emergency level descriptions, which are green, yellow, and red indicate different levels. Then, the app will request the patient's location via GPS on their device. The system will effectively sort available ambulances based on the closest distance to the patient. It will give choices from government sectors and also private sectors available. For example, the user choose Reno services. The user choose yellow level and the user can state additional notes to the driver. So in this case the driver rejected the request. When the driver choose to be unavailable, their service will be not on the list on user's interface. Lastly, when the driver choose to accept the case, a notification will pop up on the user's screen. So that's how Ambulan Ku works.
So thank you very much. So this is the flowchart, which is just the visualization and the simplification of the previous video from start to finish.
For our methodology, we develop our software in Dart language in Flutter based on our design requirements. So both caregiver and ambulance driver will interact with the Firebase web server and Google Map console. For the architecture, so we have the main Dart first access, and then from there we can access 5 different screens, which is login, feature, profile, emergency, and finish screen, each having their own logic and widgets. For the use case diagram, caregiver can order ambulance while driver can accept or reject the order and set their availability. And then register account and real-time location update is a shared functionality the two of them have. Admins can then view record and do analytics. For our conceptual business model, caregiver and ambulance driver will conduct intermediate business between the two of them, and owner will charge ambulance driver for using their platform to reach out to their potential customer.
For the validation plan, for the first user needs, which is ambulance sorting, we believe that the system effectively sort available ambulance based on the closest distance. And to verify that, we will make sure the options provided are from all providers. And measure the accuracy of the distance calculation algorithm by comparing the calculated distance between user location and also available ambulance using detected coordinate with actual distance. We are right if the system correctly sort the available ambulance in ascending order on top based on the closest distance to the user location. Precise user location detection, we believe that the system accurately detects the precise location of users. To verify that, we will make sure the detected user location with the actual location is accurate and measure the percentage of correctly detected user location compared to the actual locations. We are right if the system achieves a minimum accuracy rate of 90% in detecting user location compared to the actual locations.
Thank you for watching Ambulan Ku presentation. Ambulan Ku.
Reviving
Reviving hope.
hope.